A stone is dropped from the edge of a roof. It hits the ground with a velocity of negative 130 feet per second. How high in feet is the roof? For this problem, we'll use a of t as the acceleration function, v of t as the velocity function, and s of t as the position function. Let's begin by listing all of the given information. Because the stone is simply dropped from the edge of a roof, the only acceleration is the acceleration due to gravity, which indicates a of t equals negative 32 feet per second squared. And again, because the stone is just dropped from the edge of the roof, the initial velocity v of 0 equals 0 feet per second. And then finally, because the stone is dropped from the edge of the roof, and we're looking for how high in feet the roof is, the initial position, or s of 0, will be equal to some constant c, where c is the roof height. To begin solving the problem, because we have the acceleration function, and the acceleration function equals the derivative of the velocity function, we can recover the velocity function by integrating the acceleration function. We can say that v of t equals the indefinite integral of a of t dt, which in our case gives us the indefinite integral of negative 32 dt. Integrating negative 32 with respect to t, we have negative 32t plus c, the constant of integration. But now we can determine the constant c because we know the initial velocity v of 0 equals 0. So if v of 0 equals 0, meaning when the time is 0, the velocity must be 0, we know the constant c must equal 0. So now we know the particular velocity function is v of t equals negative 32t. For the next step, we'll determine the time at which the stone hits the ground, because we'll use that time to determine the constant c, which represents the height of the roof. We know when the stone hits the ground, the velocity is negative 130 feet per second. To find the time when the stone hits the ground, we need to solve the equation v of t equals negative 130. This gives us the equation negative 130 equals negative 32t. Dividing both sides by negative 32, we have t, the time at which the stone hits the ground, is 4.0625 seconds. Again, this is when the stone hits the ground. And now for the next step, we'll begin to recover the position function s of t using the velocity function. Recall the velocity function equals a derivative of the position function, which indicates we can recover the position function by integrating the velocity function. S of t equals the integral of v of t dt, which in our case gives us the integral of negative 32t dt. Integrating with respect to t, we have negative 32 times t squared divided by 2 plus c. Simplifying, we have negative 16t squared plus c. So again, now we know that s of t equals negative 16t squared plus c, where again c is going to be the initial height, which is also the height of the roof. But we also know at time 4.0625 seconds, the stone hits the ground, which indicates s of 4.0625 must equal 0. We'll use this fact to determine the value of c, which again will give us the initial height, or the height of the roof. So we know that s of 4.0625 must equal 0, which gives us the equation 0 equals negative 16 times the square of 4.0625 plus c, which indicates that c is equal to positive 16 times the square of 4.0625, giving us c equals 264.0625. So again, now we know the position function is s of t equals negative 16t squared plus 264.0625, and therefore C is the initial height, and therefore also the height of the roof. Notice that S of 0 is equal to 264.0625. Again, this indicates at time 0, meaning right when the ball is dropped from the edge of the roof, the height is 264.0625 feet. So for the final answer, the roof is 264.0625 feet high. I hope you found this helpful.